Hello friends, welcome back to our channel. In this lecture we will discuss about decoders. Okay, what is a decoder and what are the types of decoder and how to implement a Boolean function using decoder. That is what we are going to see in this lecture. Okay, so what is a decoder? Decoder is nothing but again to, like we have seen the implementation of a Boolean function using multiplexer. Like multiplexer has one property, like it has 2 power n inputs, n selector lines and 1 output. Similarly, decoder is a digital circuit which has n inputs and 2 power n outputs. Okay, n inputs and you get 2 power n outputs. The decoder generates 2 power n outputs. Okay, n inputs and 2 power n outputs. Okay, and most important thing is the decoder works with an extra signal called as enable. Okay, so when enable is equals to 0, then output is equals to 0. All the outputs are equal to 0. So okay, and when enable is equals to 1, then only decoder will be on. Decoder is on and you will get an output. Okay, you get an output. Okay, so n inputs and 2 power n outputs you will be getting, right? So what are the types of decoder? Like you have a 2 to 4 decoder, 4 to 3 to 8 decoder, 4 to 16 decoder and all. Okay, first of all let us start with a 2 to 4 decoder. That means 2 inputs. Okay, let us take A and B are the inputs and 4 outputs, y0, y1, y2 and y3. 2 to 4 decoder, right? Like I told you, my decoder works with an enable signal, right? So let us try to draw the truth table, then we'll go for the circuit diagram and what are the outputs and all. Okay, so the truth table goes like this: enable signal A, B, y0, y1, y2 and y3. Okay, so when enable is equals to 0, irrespective of your input A and B, the output is always equal to 0. Okay, when enable is equals to 1, if the input is 0 0, then y0 will be 1. Okay, y0 will be 1. Okay, and the rest of the outputs are 0. What is y0? Y0 is nothing but A bar into B bar. This is A bar into B, this is A into B bar and AB, the 4 outputs. Okay, 4 outputs, right? That we will see. When enable is equals to 1, when the inputs is 0 1, this is 0 1 0 0. Okay, from the truth table also we can write the output equation. Okay, so when the enable is equals to 1, enable is equals to 1, when the input is 1 0, I get an output called 0 0 1 0. When the enable equal to 1, when the input is 1 1, you get 0 0 0 1. So this is the truth table. Okay, from this truth table you can also write the output equations. Like I told, y0 is equals to A bar into B bar and y1 is equals to A bar B. Next y2 is equals to A into B bar and y3 is equals to A into B. Okay, for all the conditions my enable input should be always equal to 1. That is most important. Okay, so what is a decoder? Decoder is nothing but n inputs, 2 power n outputs. Okay, 2 power n outputs, right? So if enable is equals to 1, depending on the input condition A and B, you get an output. Okay, A bar, B bar and all, right? So now let us draw the diagram here. Okay, so I will have an enable signal. Okay, and like this, this is okay. Let me take A bar and B bar here. Okay, so what is this? A bar into B bar into, always you multiply and enable. This is an AND gate. So this will be my y0. Okay, enable is multiplied, enable should be equal to 1. correct. Next, you see here 0 1, this is 0 1 and enable, this is y1, and 1 0, this is 1 0 with an enable. You give it to an AND gate, this will be your y2, and the last one for 1 1 case 1 1 and enable is equals to 1. Okay, this will be my y3. So this is the circuit diagram of the decoder. Okay, like you have drawn the block diagram, internally this particular circuit will be present in the block diagram. Okay, so this is the circuit diagram of the 2 to 4 decoder. Similarly, you can have 3 to 8 decoder also. Okay, 3 to 8 decoder also. Okay, same fashion, just I will draw the block diagram. Okay, 3 to 8 decoder, 3 to 8 decoder. So if the inputs are 3, then you get 8 outputs, 1 2 3 4 5 6 7 and 8. Okay, so A B C, so your outputs are like, if it is A B C, then you have like y0 y1 y2 y3 y4 y5 y6 and y7. Okay, starting from A bar B bar C bar to A B C will be my outputs for the 3 to 8 decoder. Okay, now let us try to implement some Boolean functions using decoder. Before going to that, how to select the size of the decoder, how to select the size of the decoder. You see here, for suppose, you see here in multiplexer we had only one input. Okay, depending on the number of selector lines, okay, depending on the number of selector lines, we have selected the size of the multiplexer. Same here, if you have, let us say, 2 inputs. Okay, if you have 2 inputs, then you will be using a 2 to 4 decoder. Okay, if the number of inputs is equals to 2, then use 2 to 4 decoder. Similarly, for 3 inputs, if my system has 3 inputs, then 3 to 8 decoder. If my system has 4 inputs, then 4 to 16 decoder. Okay, like this you will be using the decoders. Okay, now let us implement an Boolean function by using decoder. Implementation of Boolean function using decoder. Okay, now you see here, for suppose f is equals to sigma m of 0 1 3. Okay, f is equals to sigma m of 0 1 3. Okay, number of inputs is equals to how many inputs here? 2 inputs, right? Because the highest number is 3, hence my system will be having 2 inputs. Okay, and you see here, so for suppose if I wanted to implement this by using decoder, so now because my number of inputs are 2, so we will be using a 2 to 4 decoder. 2 to 4 decoder. Okay, 2 inputs A and B, and what are my outputs? I have 4 outputs. Initially, if you see, I have only one output, F. Okay, now but F, if you see, this is A, B and F. Okay, 0 0 0 1 1 0 1 1. Now this is 0 1 3, that means at 0 1 and 3 I have a 1 output, right? So what you do is simply amend your output onto the decoder outputs. So this will be at 0 1 and 3 you will be having a 1, at the rest of the places you have a 0. Okay, so this is the implementation, simple implementation. Okay, similarly, for suppose if you wanted to implement half adder using decoder. Now what is half adder? Half adder is nothing but, you see here I have two inputs A and B. Sorry, this is half adder and two outputs. This is sum and carry, right? So my system has two inputs. So I will be using an 2 to 4 decoder, right? 2 to 4 decoder. So this is A and B are my inputs. What is my output here? I have two outputs. Sum is equals to A XOR B, that is equals to A bar B plus A B bar, correct? Carry is equals to A into B, correct? So you see here I have this is A bar into B bar, this is A bar B, this is A B bar, and this is A B. Okay, this is A bar into B bar. Now how to, you see here the beauty of decoder is nothing but, here in multiplexer what we did, for each and every output we used one multiplexer, because our multiplexer has only one output. But in decoder, though my system has two outputs, okay, sum and carry, we will be using only one decoder to implement this particular half adder. Okay, so you see here what is my sum? A bar B plus A B bar. So what I will do is I will simply give it to an OR gate and then I will call it as sum. Okay, and this is A into B is my carry output. Okay, this A into B is my carry output, and this is addition we have given. So this will be equal to 1 and this will be equal to two outputs, right? This is always equal to 0. Okay, this is the implementation of an half adder using 2 to 4 decoder. Now let us try to implement like generic questions in which end semester examinations will be asked. Implement like 3 to 8 decoder using 2 to 4 decoders. Okay, so what is this? 3 to 8 decoder means I have 3 inputs and 8 outputs, and I will be having an enable A, B, C, right? Starting from A bar into B bar into C bar to A, B, C, you will be having the outputs. Okay, so now I need to implement by using 2 to 4 decoders. What is a 2 to 4 decoder? Here we have only 2 inputs here. So 2 to 4 decoders are given. So 8 outputs okay. 8 outputs are okay. Okay, now we need to adjust with the inputs. So what you will do is, initially if you see here, I will give this as B and C input. The other input is like enable signal will be used as the other input. This is A input and this is the enable signal. Okay, you see here when enable is equals to 0, the upper half of the decoder will be on. The upper half of the enable, this particular decoder will be on, right? This particular decoder will be on. When enable equal to 1, okay, enable equal to 1, then this decoder will be on, the rest of the outputs are 0. Okay, so this we can see with an example. For suppose implement f is equals to sigma m of 0137 by using 2 to 4 decoders. Okay, 2 to 4 decoder. Okay, you see here it is simple to implement. What I will do is I will take 2 to 4 decoder, another 2 to 4 decoder. Okay, I have two inputs here, so this will be BC, and one input will be given as the enable signal, the third input. Okay, this is enable, this is A. 1 2 3 4, 1 2 3 4. Okay, so what is this? 0 1 2 3 4 5 6 and 7. So at 0 1 3 7, at 0 1 3 and 7 I have a 1, at rest of the places I have a 0. Okay, this is the implement. And verify the same thing using a truth table also. So the truth table goes like this. You can see here A, B, C. Here A is nothing but my enable signal, okay, and my Y 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, so what is my question? Question is like F is equals to sigma 1 m of 0 1 3 7. Okay, 0 1 and 3, sorry, this is 1 1 and 7, and the rest of the places are 0, correct? So when enable is equals to 0, so when enable equal to 0, you get an output. When BC equal to 0 0 0 1 1 0 and 1 1, you get the output from this particular 2 to 4 decoder. So when enable is equals to 1, you get an output from this particular decoder. Hence this is the implementation of a Boolean function. Usually the number of inputs are 3, but we have implemented the same thing by using a 2 to 4 decoder. Similarly, in your examinations you might be asked implement 4 to 16 decoder using let us say 3 to 8 decoders, then we'll go for 2 to 4 decoders. Okay, 3 to 8 decoders. Okay, so 4 to 16 decoder we need to implement by 3 to 8 decoders. Directly I will start with 3 to 8 decoders. Okay, 1 2 3, and I have another 3 to 8 decoder, 1 2 3. Okay, this is I have 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. Okay, 16 outputs are there. So the inputs will be BCD here, BCD here, and the A input will be used as the enable signal. Okay, so when A is equals to 0, you get the output from here. When A is equals to 1, you get the output from this particular decoder. Okay, now let us try to implement 4 to 16 decoder using 2 to 4 decoders. Okay, 2 to 4 decoders. This is a bit tricky. You can see here. So total number of decoders, how many decoders we have to use, I will tell you. Here we need to use 5 2 to 4 decoders. How we shall see. Okay, 2 to 4 decoder, 2 to 4 decoder, 2 to 4 decoder, and this is 2 to 4 decoder, right? So this is 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. Okay, so here I have 2 inputs, right? So what are those inputs are? This is C D, C D, C D, C and D. Okay, now what you will do is at the input side, what you do is you use another 2 to 4 decoder where my inputs are A and B, like A and B, and this 2 to 4 decoder has 4 outputs, and this will be given as the enable signal. The outputs of the first 2 to 4 decoder is given as the enable signal to rest of the decoders. Okay, so you can see here. So when A and B is 0 0, then you get the output from this particular decoder. So when A and B is 0, 1, then you get the output from this particular decoder. When A and B is 1, 0, then you get the output from this particular decoder. When A and B equal to 1, 1, then only you will get the output from this particular decoder. So this is the implementation of 4 to 16 decoder using 2 to 4 decoders. Most of the examinations are asked these particular questions, and also in some gate level questions also we can expect such type of questions. Okay, so let us take another example. Okay, let us implement full adder using decoder. Okay, so full adder means how many inputs? 3 inputs. What are they? A, B, C in, and I have 2 outputs, sum and C out. Correct? Because 3 inputs, so I will be using an 3 to 8 decoder. Right? So this is A, B, C in. Okay, I have an enable signal here. 1, 2, 3, 4, 5, 6, 7 and 8. Okay, 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so what is the full adder truth table? The full adder truth table goes like this: A, B, C in, sum and C out. Okay, so this is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1. Correct? So what is sum? This is 0, 1, 1, 0, 1, 0, 0, 1, and C out is 0, 0, 0, 1, 0, 1, 1. Correct? So you see here what we have to do. What we have to do is simply here this is 0 at 1, 2, 4 and 7. 1, 2, 4 and 7. You give it to an OR gate. So this will be equal to sum. Okay. And next 0, 1, 2, 3, 5, 6, 7. The 3, 5, 6 and 7 are given to another OR gate. This will be my C out. Okay, simple implementation. Directly you connect your outputs to an OR gate, then you can implement an 3 to 8 decoder. Sorry, you can implement an full adder using 3 to 8 decoder. Okay, so what is the difference? Okay, now I have multiplexer and I have a decoder. Okay, if you ask which is better, okay, multiplexer or decoder? Multiplexer is having only one output. Okay, for suppose if you take the example of a full adder only, okay, mux, how many number of multiplexers should I use? So full adder using mux, okay, 2 8x1 mux I need to use. Okay, 2 8x1 multiplexers are used. Okay, and decoders 1 3 to 8 decoder is used. Okay, so if you straight away see the implementation, multiplexer is like 2 8x1 multiplexers means more number of logic gates, more cost and all. Okay, here I can be implementing a simple by 3 to 8 decoder only I will be implementing, that is lesser costly. But in general multiplexer is used over decoder. Okay, because you are, what you are doing is you are giving the outputs all together to this particular OR gate. Okay, for suppose if this particular output is driving another input, another digital circuit input, okay, then the, for suppose the if I have like I have a simple 2 to 4 decoder, I have like let us say I am using an OR gate here. Okay, and I am having one half adder here. Okay, for suppose this is my input to this particular gate, and this let this be second input. Okay, now you see here, this particular input is coming faster than this particular input, correct? Okay, this is because this is I am having a gate, so each and every gate has a gate delay, and this input is coming slower when compared to this input. Okay, so this input has to wait until and unless this input is arriving. Okay, so though it is using lesser number of decoders to implement the full adder, but if that particular circuit is driving another digital circuit inputs, then that is a disadvantage to us. Okay, so you might get the output might be wrong. Hence multiplexers are preferred over decoders when coming to real time. Okay, there should be no delays, there should be no gate delays, and there should be no fan out conditions. Okay, fan out problems. Okay, so I hope you have understood the concept of decoder, and also how to implement a Boolean function using a decoder and all. So if you have understood the concept, then please like the video, share it to your friends, and also subscribe to the channel. Thank you for watching.